Today we're looking at Unit 8, Lesson 11, with our aim being able to compare the relative sizes of two different numbers. Our think about it asks us, how many times larger is 6 times 10 to the 8th power compared to 3 times 10 to the 7th power? When we're comparing our values 6 times 10 to the 8th and 3 times 10 to the 7th, what can we compare? First, let's look at our multipliers that we know are the numbers that we're multiplying times 10. When I'm comparing 6 and 3, how much bigger is 6 than 3? We know that that's obviously 2 times larger. Now, let's compare the magnitude. So looking again at the power of tens that we're multiplying by. If I have 10 to the 8th in comparison to 10 to the 7th, how much bigger is 10 to the 8th than 10 to the 7th? As you can see, I've set up our comparison of 10 to the 8th and 10 to the 7th as division. I can use the exponent rules and know that when I'm dividing something by the same base, it's the same as subtracting those exponents. So I can see that I have 10 to the 8 minus 7, which is the same as 10 to the 1, or just 10. That means 10 to the 8th is 10 times bigger than 10 to the 7th. If I were to put all of that together, I would know that 6 times 10 to the 8th is, as I can see, 2 times 10 times larger than 3 times 10 to the 7th. Again, because 6 is 2 times larger than 3, and 8 to the 10th is 10 times larger than 10 to the 7th, I know that everything together, 6 times 10 to the 8th, is 2 times 10 times larger than 3 times 10 to the 7th. Obviously, writing 2 times 10 times larger doesn't make sense. I just simplify that down so that I have 2 times 10, which is 20. 6 times 10 to the 8th power is 20 times larger than 3 times 10 to the 7th power. Now that we know that 6 times 10 to the 8th is 20 times larger than 3 times 10 to the 7th, let's look at part B. It asks, how could you use this to approximate how much larger 591,873,400 is in comparison to 31,880,000? That if it says we need to approximate, that means we're going to estimate or round our numbers. Let's go ahead and turn those large numbers into scientific notation. Now that I can see my two numbers in scientific notation, I can tell that I didn't really save a lot of time writing my number out because I have large decimal places. So we can do what our problem says and round or approximate our numbers out. So if I was to round my multiplier for my first number, I can take this 5.91 and round it to a whole number of 6. Again, keeping the magnitude the same. So now instead of 5.918734, I can just write 6 times 10 to the 8th. Again, looking at my second number, I have 3.188. And if I want to round that to a whole number, I'll round down to 3 times 10 to the 7th. I can see that when I round my two numbers, I have the same values that I had in part A. So if I can use my approximation to find the same comparison between our two numbers. Since these numbers estimate to the same values from part A, I know that 591,873,400 is approximately 20 times larger than 31,880,000. Again, because my values that we found estimate to the same values as before, we know that our comparison between our values is going to be approximately the same size. Coming up with a key point that answers how we can use estimation and scientific notation to compare very large or very small numbers. Today is going to be that estimation can be used to compare numbers in scientific notation by comparing multipliers and the powers of 10. Go ahead and turn to your interaction with new material, and we're going to go through this a little bit more in depth.